Hey guys, in this lesson we would understand how to solve polynomials. We know polynomials can be linear, quadratic, cubic, quartic, quintic, or more type. However, since we just have to cover up till quintic polynomial functions, so we will just talk about how to solve polynomials up to degree 5. Degree 5 polynomial solving is a long process. That's why we just go up to degree 4. Now let's first understand what is meant by solving. If we have an equation 3x plus 4, we know this is a linear polynomial example and we are asked to solve this. Solving means we are finding the value of x. Now we cannot find the value of x until we have this in the form of an equation. So we need to know what is going to be on the other side of the sign. Now, if we know that the equation is 3x plus 4 equal to 0, how do we solve for x is, we isolate x, so move everything on the other side, and we get x equal to negative 4 over 3. And we notice here that we would get one x value for a linear polynomial function. Let's say we're asked to find out the value of or solve a quadratic polynomial function, and it is given to us like this. How we would solve for this quadratic polynomial function is, because we notice that x is at two different spots, one is with the power 2 and one is with the power 1. So if we try solving for x in this way, it becomes really difficult to find the value of x. So what do we do is, we bring this 4 on this side and make the other side of the equal to sign a 0. This would give us 3x squared minus 2x minus 3 equal to 0. Now still, if we want to find the value of x, we cannot isolate x. So what is the best way of solving a quadratic polynomial is to first convert it to factored form. If factoring of this quadratic polynomial is not possible, then we use quadratic formula. So in order to solve a quadratic polynomial, we would either change it to factored form, and if factoring is not possible, then we would be using quadratic formula. We notice that here we try to factor trinomial. 3 times 3 is 9, and the product is a negative 9. Sum is a negative 2. There is no way we can find out two such factors who will have a product of negative 9 and sum of negative 2. So therefore, in this particular example, factoring possibility is ruled out. So we would be using the quadratic formula to solve this. We know quadratic formula is negative b plus minus square root of b square minus 4ac over 2a. So what we have to do is just take in a, b, and c values and sub in into the formula to get the value of x. Negative b means negative of negative 2 plus minus square root of b is negative 2 square minus 4, a is 3, c is negative 3, divided by 2a, a is 3 again. So we would be left with 2 plus minus square root of 4 plus 4 times 3, 12 times 3 is 36, divided by 6. This would give us 2 plus minus square root of 40 over 6. We can write it as 2 plus square root 40 over 6 and 2 minus square root 40 over 6. When we put this on the calculator, we would get 1.39 for the first one and negative 0.72 for the second x value. So one x value is 1.39. and the second x value is negative 0.72. Therefore, we notice that when there is a linear polynomial, we get one value of x. When there is a quadratic polynomial or degree 2 polynomial, we get two values of x as an answer. If we have another type of polynomial example that is factorable, for example, this one is factorable, 2x squared minus 25. So this is 2x whole square is 4x squared, 5 squared is 25 is equal to 0. We can write it as 2x minus 5, 2x plus 5. This, you know, from the previous grades is called difference of square factoring. If you need to review factoring techniques, you can visit our factoring polynomials playlist in the channel where it explains different types of factoring in details. Now, when we have this given quadratic equation in factored form, that is a bracket form, then we put each bracket equal to 0 because this is a product of two factors equal to 0. Whenever the product of two things is equal to 0, then either of the number is equal to 0. Therefore, we would put 2x minus 5 equal to 0 first. Solve for x, that gives us 5 over 2. And 2x plus 5 equal to 0, solve for x gives us negative 5 over 2. So here also we got 2x values because this is a degree 2 polynomial, and this is where we do factoring first and then we solve for x. So solving means we are finding the value of x, and we notice that it's easier to solve for x when we have the equation in factored form. This was all about linear and quadratic polynomials. What if we have a cubic polynomial function? We know this is a cubic polynomial function. We are asked to solve this equation. Remember, whenever we are asked to solve for any polynomial, the right side or one side of the equal to sign should be a 0 always. If it's not a 0, then we have to make it a 0. Now, once we have three brackets equal to 0, we would just put one bracket equal to 0 one at a time and solve for x. So here x equal to 0 is directly an answer. X plus 5 equal to 0 means x equal to negative 5. X minus 1 equal to 0 means x is equal to 1. We notice here that we get 3x values because it's a degree 3 polynomial. Now this question is a cubic polynomial given to us in factored form. What if the cubic polynomial is given to us in standard form? Let's take up that example. Let's say we have a question x cubed minus 8x squared minus 3x plus 90 equal to 0. We have to solve for x, and we see that this is a cubic polynomial which is not given to us in factored form. So our first step is to factorize it. Once we get all the factors, then we'll put each factor equal to 0 and solve for x. Factorizing technique we have already discussed in the previous lesson, so let's quickly go over all the steps to factorize it. We know here there is no number, so 90 divided by 1 is a 90. We will be working on the factors of 90, plus minus 1, plus minus 2, plus minus 3, plus minus 5, plus minus 6, plus minus 9, plus minus 10, plus minus 30, plus minus 18. So on, we have lots and lots of factors of 90. We will try checking plus minus 1 and substituting it in place of x. That's called the factor theorem. So we would be applying factor theorem for each of these factors. And once we do trial and error, we would be able to find out that x equal to negative 3 would give us this function equal to 0 value. Let's check that. So when we sub in negative 3 as x, it would give us a negative 27. This gives us a negative 99 plus 99, and that would be equal to 0. Therefore, x equal to minus 3 is the first factor. We would be using the first factor with synthetic division on this polynomial function to get the second and the third factor. So the numbers that we have to work with, 1, negative 8, negative 3, 90. We'll bring the first number down as is. Negative 3 times 1 is negative 3. We get a negative 11. Multiply this, we get a 33. This gives us 30. When you multiply negative 3 and 30, we get a negative 90. When we add it, we get a 0. Therefore, the quotient that we get is 1x squared minus 11 plus 30. So now the polynomial x cubed minus 8x squared minus 3x plus 90 equal to 0 can be written as x plus 3 because the first x value was negative 3. So we write it as a factor with the opposite sign, x plus 3, and x squared minus 11 plus 30. As we know, the product of both the divisor and the quotient would be equal to the function if the divisor is a factor of the polynomial function. Then we can factor this out. We know this is 30. Product is 30, sum is negative 11. Negative 5 and negative 6 would be the factors. So x minus 5, x minus 6 is equal to 0. Now we've got the three factors. All we have to do is just put these three factors equal to 0 and solve for x. So we got x1 value, x2 value, and x3 value. 3 x values for a cubic function, and this is the answer for the solution of this cubic function. Now we also know these x values are nothing but these are called x-intercepts. So these will be the points where this function is going to meet the x-axis. This function is going to meet the x-axis at negative 3, 5, and 6. This particular function was factorable In a quadratic function, we noticed if the function is not factorable, then the other technique that we use is quadratic formula to solve for x. However, when it comes to cubic functions or quartic functions, and we are unable to factor them out using all this method, then what we do is we just use a graphing calculator or a graphing technology to turn the function into a graph using the graphing technology and check where the graph is going to meet the x-axis. Wherever it meets the x-axis, that is the solution of the particular function. So the process to solve a polynomial function that is degree 3 and up, there are two ways, that is factoring or graphing using technology. And the factoring technique stays the same no matter if it's a cubic function or if it is a quartic function. The only difference would be is to use the trial and error and repeat these steps 2 times in order to solve for a quartic function.